Hi, and welcome to Varjo's Boeing Starliner webinar. My name is Anna-Leena Kuronen, and I'm heading communications here at Varjo. And we are streaming this live from our headquarters here in Helsinki. Thank you so much for joining us today. I'm sitting here with Varjo's co-founder and chief product officer, Urho Konttori.
Hi guys, pleased to be here.
Great to have you here. And very soon we are about to dig into what is perhaps one of the most exciting use cases for Varjo's virtual reality headsets. So Boeing is today able to train astronauts for the entire space flight using Varjo's human eye resolution VR powered by Unreal Engine. And this is the first time this has been possible. But before we jump right in, here's a quick preview of our agenda for today. So first we'll hear a couple of remarks from Urho and Sebastian from Unreal Engine. And after that, we'll have a 20-minute presentation from the developers of the Boeing Starliner VR training program. And this presentation has been pre-recorded to fit the time zones between Helsinki, USA, and Australia. We'll hear Connie Miller, Leighton Carr, and Steven Saislav presenting. And after the presentation, we'll have a live Q&A session where Connie, Steven, Leighton will join us to answer any of the questions that you have about the VR training program, as well as we have a couple of experts from Unreal Engine and Varjo joining us to answer all of your questions. So you're welcome to use the Q&A tool in the Zoom webinar throughout the session. Please share your questions and we'll get to them at the last 20 minutes of the presentation part. And just a quick practical note before we start. If you want just the speakers to be visible, you can use the gallery view in the Zoom and choose to show only active speakers. So that way the experience should be as seamless as possible. But now it's the right time to welcome Sebastian from Unreal Engine to this discussion with Urho. So Sebastian, if you could unmute yourself and also show your video, that would be fantastic. Can you hear us, Sebastian?
Yes, I can hear you. Hi, everybody. Thank you very much for this opportunity to chat with you today. It's a pleasure to be here.
Wonderful to have you here. Urho and Sebastian, Varjo and Unreal have been collaborating for over 4 years to enable the most demanding training and simulation applications in VR and XR. But this is definitely one of the most thrilling use cases we've ever seen for our two companies. Could you reflect on what you personally find most exciting about this collaboration with Boeing Starliner? Urho, if you can start.
Okay, so happy to do that one. I mean, at Varjo, we have been doing the headsets to enable pilot training, whether it's in the defense sector or in the civilian aviation. And it's incredible to be able to solve the transformation in that industry. But when we think about the manned space flight, which is what we're talking about, it's like the most mission critical training that ever exists. You need to be able to train absolutely everything to the perfection and to have everything as realistic as possible. And from our point of view, of course, if VR and mixed reality is ready for manned spaceflight training, it's ready for absolutely everything. And that's so exciting that together with Epic and Unreal Engine, as well as with Boeing, we have been able to prove this point. And I'm so proud of what we have achieved. This will have fantastic consequences to the whole industry, I believe.
Great. Sebastian, what do you find most exciting about this case?
Well, I agree with you, Urho. You know, space is part of our youth dreams. Space exploration was a huge focus, you know, and is still a huge focus of our collective imagination. It's in everybody's dreams, right? Astronauts, right? One of the roles that makes people dream the most. But there's something special. In the last 10 years, an acceleration, new challenges across the space industry value chain, have resulted into exponential expansion of our ecosystem, right? There have been, accompanied by more affordable commercial access to space, challenging and changing manufacturing philosophies that we see at Boeing and with other, manufacturers and more cost-effective downstream solutions. So new participants like you guys at Varjo and us at Epic Games and others are developing new capabilities to meet these evolving customer requirements. So currently, however, the community still lacks a lot of capacities to support the growing demand from the new player for more space systems, components, launch new services, operations, and simulation. So it's creating a cascading effect on the space launch industry in terms of demand. And we're always looking for new friends to play with. So it's a pleasure to be here and to see all this audience today, because I think this conversation will open more questions and more discussions, and we're really looking forward to it.
As are we. That's great. And if we look at some of the media coverage that we got for this case, when we first told the world in public that we are collaborating with Boeing Starliner program, this was back in June this year. It's obvious that also the public interest for this case has been tremendous. So why do you, Urho and Sebastian, think that this is a big deal for the entire VR XR industry, but also for the whole future of simulations? Urho, do you want to start?
Yeah, happy to start. So I'm reflecting just what Sebastian said. So like astronauts is something that I would say that almost all of us has dreamed to be as kids. It's something to aspire to and something that really blows and blossoms the imagination of the people. And that's why it's so interesting for everybody, not only in the technology press or professional press, but in the mainstream press alike. So now the important point is that this message has been getting across to everybody in the world that now virtual reality is ready to train the most demanding cases. And this resonating throughout the world it's going to be now creating a new era in the training overall.
Great. Anything to add there, Sebastian?
Well, I mean, there are a couple of things that are obvious. I mean, great success like that in terms of press coverage are coming from great marketing. Good job, Anna. Having three, more seriously, having three innovators, talking together, Boeing, Varjo, and Epic, the audience is de facto listening, right? And there is a lot of things happening only by the fact of this, collaboration that's been established there in the context of this project. But more on top of that, there's one thing that Urho alluded to is the fact that we collectively start to realize that VR and AR and mixed reality globally is not only a toy or a nice gadget. It can become a tool. It can become something serious that allows people to build additional knowledge and to gain a way to augment the learning transfer. And that's a big change. That's a big articulation that we see these days. And what the popular press is catching from that is the fact that, it's serious actually. It's not beautiful pixels and fancy devices. It is actually a serious program and project that people start to realize is bringing value to the global community.
Yeah, exactly. And taking VR from this typical view of being a gaming entertainment tool into serious, perhaps the most serious training application there is, the most demanding simulation that there exists.
Absolutely.
Great. So this is truly the world first for Boeing to be able to train for the entire space flight. Previously, NASA has been training astronauts using virtual reality, but in more game-like scenarios, like practicing moonwalks, for instance. So Sebastian and Urho, could you finally speak a little bit about the importance of the highest fidelity visuals for this type of demanding professional applications, such as the Boeing Starliner VR training? And why are Unreal and Varjo the perfect fit for this kind of application?
Yeah, I mean, really good question. When you do training, it's one of the most important thing is that all the training needs to be positive. So negative training means that you will learn a behavior that you actually wouldn't want to be replicating in real life. And this is, for example, learning a different muscle memory that instead of directly reaching a button, you reach it with an arc or something like this. And the thing about the fidelity, the human eye resolution that Varjo headsets provide, so that when you see a text, small font text, you see it the same way in real life as you see in the virtual world. It means that now the whole training can be done exactly the same way as you would if it was a real physical cockpit and everything was real around you. And this is what makes it positive training. So so that everything is replicated exactly as in real life. And of course here, the incredible rendering fidelity of Unreal Engine, of course, really brings things to lifelike quality. And then with the human eye resolution VR headsets of Varjo, then you see it exactly as Unreal Engine renders.
Great, Sebastian?
Yeah, no, it's
Comment
true.
from you for this.
I mean, there's a lot of points here, and I see in the audience that we have today a lot of very seasoned simulation people. I'm not saying you're old, guys, but you're seasoned. And one thing that's important, you know, when you come from a very heavy simulation background, which is my case, you know, I've been 20 years developing simulators in some capacity as a software engineer, and you see an evolution, a very interesting evolution, where in the past you had a very particular paradigm between the gaming world and the simulation world on the other side. Both needed real time, both wanted real time, and both were real time. One of them was really focusing on, you know, entertaining people and making sure that we grab attention of players and gamers. And we had always a strong focus on beautiful images, beautiful content, and rich visuals, right? So realism in the visual side of things. And on the other side, in the simulation side, we're really focusing on having systems that were accurate, physically correct, precise. And in the past, when I started, we had simulators that looked like a blue line saying the horizon and a green wireframe saying the ground. And your goal as a pilot was to make sure that you didn't collide both. It meant you were flying, right? So that's the type of visual we were dealing with in simulation 20 years ago. And it was not possible at that time to reconcile these three concepts: real-time, accurate, and great visuals. Things evolved. You know, computer graphics capabilities, as well as the acceleration and the augmentation of the capacity of our algorithms today. And now we can finally reconcile these three terms. It's very new, it's very recent. Both the world of simulation and the world of gaming are not used to it yet, but it's coming, and that's what's happening. And that's exactly what this project was, you know, demonstrating: the capacity to have accurate, real-time, and beautiful graphics. And I think it's a very big change. And using head-mounted displays capabilities that allow you to deploy that in a simpler way is really, really accelerating the adoption of these technologies.
Great, it's all coming together. And as one of the attendees said in the chat, what a great time to be alive.
So, absolutely, yes.
Thanks so much for being so active already in the chat window. Great to see so many of you joining from UK and Luxembourg to United Arab Emirates to Houston, etc. So great to see all of you here. Thanks Urho and thanks Sebastian for these introductory remarks. We will soon get you back here, but now it's time to give the stage to the Boeing Starliner experts. So you'll hear a presentation, 20-minute presentation by Connie Miller, Leighton Carr, and Steve Seislav. Please share questions through the Q&A throughout this, and we'll answer them at the end of this presentation. But enjoy.
Welcome Varjo webinar attendees. I am Steve Seislav. I am a communicator at Boeing. I work here in Houston doing astronaut training with the crew of Starliner. We also work the International Space Station because Boeing has been involved with the International Space Station and really human spaceflight for many decades. And this is a chance with Starliner for us to train the crews to fly on a Boeing spacecraft. What we're doing today is looking at some of the work that's gone into developing a simulator like nothing else, because it's a simulator that will fit in the suitcase. And you're going to see how the simulation, why it's important in space flight, and what it took to make it something that can go anywhere in the world for a crew that will train as private astronauts, as regular NASA astronauts, without having to come to places like Houston here for all of their training. So we're going to jump right in. What you're seeing here is the International Space Station. It orbits above the Earth 250 miles, and it's going 17,500 miles an hour, Mach 25. It covers 5.5 miles every second. But what we're here to talk about today is the simulation, the training that goes into these space flights. With me are two of Boeing's finest developers. Connie Miller is here in Houston. She's going to talk about some of the requirements that go into a virtual reality trainer as complex as this and able to fulfill the needs of a crew that is training for this very demanding mission. And with us from Australia, from Boeing in Australia, is Leighton Carr. And Leighton is part of the software development team that got all the programs to work together and put it all into a bundle that could do everything that astronauts needed to do. This is a big step. And as you probably know, people have been going into space since 1961. And what you see on the screen now is the very first simulator. This was a Mercury Capsule. Mercury was the very first human spaceflight program for NASA. This was a single astronaut going up into space, a mission as short as 15 minutes or as long as 24 hours. So a far cry from what we do today, and the simulators are a far cry from what we need. Today's simulators really have to do a lot of reactionary stuff, a lot of planning, a lot of unknown situations that can develop. But for Mercury, it was basically learning the cockpit layout, and that's what you see here. For Apollo, again, far more complex missions. So you had two spacecraft that astronauts would be flying in, the command module and the lunar lander. Next up, a big order of magnitude leap for the Space Shuttle simulator. Here you see one of the astronauts training on the flight deck, and that flight deck is part of the motion-based simulator that was there in Building 5, same area as you saw for the Apollo simulator. That one was on hydraulics, and it would shift and turn and give astronauts the same kind of sensation that they would have when they were flying the shuttle. And this has given way to our Starliner simulators. These are our physical simulators, and we have them here in Houston. With the 3 astronauts, you see that's our crewed flight test. That's Chris Ferguson in the middle, our Boeing astronaut, and then Nicole Mann and Mike Fink. And they're NASA astronauts. They're working on a Starliner flight deck, a much smaller set of consoles than had been in the past. With Apollo, you're talking about 2,000 switches and a control panel that went all the way across the spacecraft. With Shuttle, you still had more than 1,000 switches completely surrounding the astronauts. So now we're seeing less than 100 for Starliner. But you still have a lot of things that you need to do, a lot of situations that you need to practice for. So that's why we have what is called the Boeing Mission Simulator. It is also tied in with mission control, so all the flight controllers can work with the crews while they're practicing for these missions. And the reason that we're doing all this, that we go through all this, is because of that complex set of instructions, set of operations, flying the spacecraft manually, if you had to the International Space Station. I will note here that Starliner will fly itself autonomously, and that's the way it's designed to do. But the astronauts have to be able to take over and still accomplish the mission. And that's why we go through a lot of this simulation. So what you're seeing here is the space station in its circular orbit, 17,500 miles an hour, like I said. And then Starliner has to go from 0 on the launch pad to orbital velocity in 12 minutes, going up into space on an Atlas V, and then steadily over the course of, for a crewed mission, 6 hours, raising its orbit and then making contact with the International Space Station. That's the operations we're looking to do, and you've seen how the simulators are, how large they are, all the work that goes into them, how important they are to accomplishing these missions. And our team has taken all of that and put it into these Varjo headsets. Right here, you can see Connie Miller, and she is, in this photo, she's using the VR headset and really figuring out what needed to be done. And Connie, tell us a little bit about how that progressed. That's a lot of operations to fit into something that can be carried in a suitcase.
Yeah, so we started out this program back in 2017 using just Oculus Rift, pretty affordable, commercially available headset. And it was great for proof of concept, showing that the idea could happen. It was a little lacking in resolution. So when we got ready to actually do some training with the astronauts, we really needed a headset that would provide us the resolution to be able to read the detail on the screens from a normal position. So we've settled on the Varjo headset here, and we're using the valve index controllers, coordinated interfacing with the simulator in Houston. It's provided a pretty good background for being able to do this.
Absolutely. And Leighton, we're showing some of the video from your early builds and some of those early software tries. Tell me about this early phase that you were working on Starliner.
Sure. So, you know, as Connie said, at this stage we were working in the Oculus Rift, and we were really just pulling together the environment. So you can see the Starliner internals here. This is us doing a multiplayer experiment with having multiple people inside the Starliner. We've got the Earth outside there, and coming up to the dock with the International Space Station. And you can see a bit of the level of detail that Connie was talking about with all of the switches and fine text on the displays. So we actually had to blow that up. You can see that big green virtual display down the bottom of the screen, something that we created and added so that you could actually read the text in those more commercial grade Oculus headsets. This was all built in Unreal Engine. We obviously use Boeing models for the Starliner, as this is our program. And then for the Earth and the space station, we use publicly available and NASA models, just to keep it relatively simple. We did do the entire Earth, so you can go on a full orbit around the planet at the correct orbital velocity, but we kept this fairly simple at this stage. As we progressed this program and wanted to move this into astronaut training, what we found also, apart from the resolution, was that the simulator fidelity needed to be much higher, so in order to train the astronauts. So we took the virtual environment and then we integrated the actual real simulation software that had been built for those physical simulators at Houston, connected all the switches, connected the displays, and then used the Varjo headset, as Connie said, to actually give them a real high resolution window into a fully, properly simulated virtual reality environment of the Starliner.
And Connie, you were looking at this from the perspective of a crew member. You work with the astronauts all the time. Mm-hmm. When you saw this the first time, and like Leighton said, it was an early build, but there had to be something that made you feel like it was possible to make that leap from the early build to something that the astronauts could depend on.
Yeah, I think from the first time we saw it and got Chris Ferguson to see it, it was readily apparent that this was definitely a viable option for training remotely. The presence, the artistic quality of the models just really gives you a true sense of presence and being there. And that paired with the Varjo headset really makes it a good experience.
And this is another look at the software development as it was coming along. Just so you can see that we're looking more behind the scenes than usual. We still have the internal stamp on it, but that doesn't apply. This is a early build. And Connie, tell me a little bit about why Chris wanted to do the remote training.
Yeah, so Chris lives in Florida, and the training, as you mentioned, happens in Houston. So if we could get this to him in a virtual environment, he'd be able to train from his office in Houston. I mean, in Florida, rather than travel to Houston all the time. And also with the multiplayer feature, he could participate in his crew members' training. As they're training in Houston, he could join in that session with a VR. And while he couldn't see them, he could see their results of their actions. So he could really participate and watch their training along with them. And then someday, you know, we'd love to get this up on the space station itself, let people practice reentry procedures after being in orbit for 6 months or something like that. And just lots of opportunities as we open up the market to potentially commercial customers. It would just let people train from anywhere.
Leighton, what did you think? What did you think when you got the task to go from this early build to something of extreme high fidelity that the astronauts could use?
Well, I was very excited. I've always, been wanting to participate in some small way in the human spaceflight program. So getting an opportunity to help with the astronaut training systems was an incredible opportunity. Obviously, it was a daunting task as well. It's a very complex spacecraft, a lot of different systems, and we really wanted to get that as right as possible. And it was a fantastic opportunity to work with the engineers in Houston to integrate the high fidelity software simulation that they use for the physical trainers with that virtual reality environment. And just really excited to see where it goes next. And just on the applicability standpoint, one of the things that has been explored and has been talked about was this actually opens up the opportunity to do Starliner training on the International Space Station itself or off Earth somewhere as well. So that remote training aspect is a great opportunity for the future of human spaceflight, I think.
Now, tell us about the transition. I put up this screenshot because, as y'all referred to before, you kind of had a screen that would come out that you could see a little bit more what the switches were. And of course, you can't have that for astronaut training because the mantra is train like you fly and fly like you train. So anything that they're not going to see in the flight, you don't want them to see in training. But you had to go to a high resolution, and I know the headset is part of that. But what are some of the aspects that you had to get to work together to go from kind of a flight deck tour to something that is operational and very usable for the crew?
Right, for sure. So there's really three aspects that we needed to, or the three main aspects we need to consider. One is the actual orbital motion of the spacecraft itself, which is something that the simulation is providing and updating and faithfully in accordance with the orbital mechanics of the spacecraft. The second one is really all of the switches and knobs and dials and buttons on the flight deck there. So each of those had to be connected through to the simulation and had to, its state had to change properly according to the simulation, all that sort of stuff. And then, of course, the crew displays, as you just mentioned, where instead of what we've got on the screen here, which is our very simple internal build that we started working on, what we needed was the actual exact crew displays. Now, those are also rendered by the simulation software. So we had to effectively import those images in real time. So every time a new image is generated for the displays in the physical simulator, we needed to pull that into the environment displayed in the virtual reality screen without losing any of that resolution as well. So that there, obviously a lot of text on the screens, and the amount of resolution you need in a VR headset to read that fine text is very, very high. So it was really only the Varjo that was going to give us that opportunity. So we actually approached Varjo quite early, and they had just kind of spoken about their upcoming virtual reality headset, and I sent them an email and asked for more details, and then talked to the founders, met them at a conference in the United States, got a demo, thought it was amazing and exactly what we needed. And then we worked through some of the alpha and beta builds, giving them feedback, integrating it with our software, testing it, letting them know what we wanted. And so we've had this great relationship with them throughout that development process, and we're really happy where the production headset, the VR2, has come nowadays. And so this is a screenshot of the actual astronaut training version of the virtual reality environment. And this is a great example. You can see how much fine text there is, and you can see why we need that high resolution headset to read all of that for the astronauts.
And that's really a big step forward, kind of from that early build to this one. I won't ask you how many versions you went through, but yeah, was it the work that you thought it was going to be when you started?
Well, it's a good question, actually. I kind of hoped. I always dreamed that we would get to an astronaut training version, but you know, I knew there were a lot of challenges on the way, so didn't go exactly the way I thought it would or hoped it would, but in some ways better, and very excited that we did get to this stage. And probably also worth noting, this is you know, deployed in Johnson Space Center for the NASA astronauts to use, as well as at the Boeing facilities in Houston, and as I think you both mentioned, out of Florida as well. So we really made a lot of great progress, and very proud of the teams in Houston and Brisbane that pulled this together.
And Connie, Shuttle had tried something like this with a laptop computer, not nearly as advanced as this. When you pulled on the headset the first time and you saw a display that looked like this, even though it wasn't completely finished yet, did you feel like you had kind of crossed a finish line, or did you see the finish in sight?
Oh yeah, it was immediately apparent that this was the way that things were going to go in the future. That you know, and taking it out of space, there's just any kind of training that you're doing in a simulator like that, being able to get the presence that you feel with a high quality VR experience was immediately apparent. It's just, it won't replace all the simulators. They'll still need to get in the physical simulator to get some tactile feedback and do some of that, but it should severely cut down the amount of time they have to spend there.
Yeah, and we're seeing here some of the interaction and the interaction, Connie, with the hand controllers moving the gloves around. You have some pretty ambitious goals in the future.
We do. You know, Varjo's come out with some another version of a headset that has see-through capability and will recognize hand movements. There are all kinds of things going in the future. We, you know, we'd always talked about someday using gloves rather than the controllers. If we could get to where we could actually use our own hands instead of controllers, that would be great. And then again, getting it into a system that could run in orbit. Just all kinds of possibilities coming down the road.
And the interaction, the teamwork. Leighton, is this something that can apply to the other different crafts that Boeing builds, that other people use, aircraft of all sorts and that sort of thing? Is this something that will translate into that?
Yeah, absolutely. The core challenges that we solved in this project absolutely apply to other aerospace craft, whether they be commercial or defense. So most of them have high resolution displays these days with a lot of information that the pilots need. Most of them have those physical switches. Most of them need complex simulations, and similar to the Starliner, most of the pilots need large physical simulators and access to those in order to do their training. So we think this is going to be a step change in the way the training is created and delivered. As Connie said, you'll still need those physical simulators for tactile feedback and for motion, but this should dramatically reduce the amount of time they have to spend in them, and also give them an opportunity to train anywhere, anytime.
Outstanding, outstanding. This is gonna wrap it up for our presentation, but Connie and I will be here with some other folks to answer questions. Again, thank you to all the Varjo webinar attendees, and thank you to Connie Miller and Leighton Carr for taking part today in this explainer, really, of this Starliner VR system. Again, nothing like this has been tried before, and we think it's really going to help crews of the future, private astronauts, get ready for the demands of human spaceflight and to go into that place where so many of us, would like to go and really take part in the wonder of adventure. Thanks again. I'm Steve Seislauf.
Hey everybody, welcome back to our live broadcast here from Helsinki. I hope you enjoyed the presentation by the Boeing Starliner team. We have the great pleasure to welcome the entire Boeing Starliner team of speakers that you just heard to our live Q&A session. So Connie, Leighton, and Steve, if you could unmute yourselves and also put on your video. And we'll have some additional experts joining this Q&A session, as mentioned. So we have Urho and Sebastian, who you heard earlier. And also we'd like to welcome Michael Wilken, who is Technical Account Manager at Epic Games.
Hello.
He's responsible for the Boeing collaboration on the Unreal side. And also a warm welcome to Jeff Bond, who's heading business development for Varjo. Jeff has been also leading the Boeing Starliner project from the Varjo team side. So I hope we have all of you on the line.
Yes, we're here.
You're all here, you can hear us well? All good, Michael, Sebastian?
Yeah.
Fantastic. So we have a huge bunch of questions that have been shared with us on the Q&A. So thanks to all of you who have been sharing your questions. We'll have about 20 minutes now to go through all of them with all of our experts here. So let's get started. First question was from Martin. I think this one is directed to Connie. So are the UIs in the training simulation linked to the actual hardware and software being developed for the spaceship's onboarding systems? And are you identifying possibilities to refine the systems that have been identified through flaws? So could you speak about that?
Sure. The VR system is hooked to the actual training software for the simulators, not the flight software, but the simulator software. So it is able to run any scenario that they can run in the physical simulators. Gives us a lot more flexibility with what we can do in VR, because we can really just recreate any scenario that they would run in any other training environment.
Great, thanks, Connie. Next question is from Julia. I think this one would be continuing for Connie as well as Leighton on the development. So what was the biggest difficulty you faced as developers and testers during the development of this simulation program?
Would you take that one, Leighton?
Okay. Gee, the biggest difficulty, probably getting the simulation integrated into the Unreal Engine environment in a multi-user condition. So when you've got two people sitting in the same Starliner cockpit, you want them seeing the same simulation state and the same, because they're meant to be in the same physical vehicle, right? And in the real world, you would have them sitting in the same physical environment. But when you want that distributed, so you want one astronaut in Houston and one in Florida, then you need to be able to share that simulation state between the two locations in real time, very, very quickly, so that as they're communicating and talking over voice, they're also seeing the same things in the virtual environment, and the Starliner is behaving the same way.
Great. A related question to that one. So Jeff Tripp is asking, do you use a secure network, some kind of encryption for remote multi-crew training?
Do you want to take that one, Connie?
Sure. We are actually, yes, running on a private network. So we are on connecting our Florida environment and our Houston environment through NASA's networks. It is not on public networks.
Great. And then we have a question for, I think, Michael and Jeff. So about the three-way collaboration between Boeing and Epic and Varjo. So how do companies like Epic and Varjo support an industry giant like Boeing? And how has this collaboration worked in practice? Michael, do you want to start?
Yeah. Well, I think, you know, in terms of logistics, of course, we support with an in-person and online, you know, support and training on a pretty large scale. But I think it's kind of important to note the overall partnership. There's a lot more engagement than this execution, which I think is one of my favorites. But you know, you have training and simulation, but you have a lot of other uses for Unreal Engine, and frankly, a lot of interest in use of Varjo as well for things like design and manufacturing reviews. You're seeing a lot of use in real time for things like AI training, as well as factory simulation, and of course, virtual production for either marketing materials or for internal training and configuration. So it's a very large landscape, and the support you know, kind of encompasses all those areas. And I think as organizations like Boeing get more mature, then you start talking about pipeline and creating, you know, efficiencies of scale. So, you know, a digital twin of, you know, products and assets can be used across the organization.
Great. Jeff, go ahead.
Yeah, I think that's great. And just one thing that I would want to emphasize also, that, you know, the thing I love about Varjo and working here is that we are really able to roll up our sleeves and support all these customers in a really individualized way. So, you know, Leighton reached out really early on, as he mentioned, to the Varjo team, like before even my involvement. And we were able to really engage with all of their problems and help them build as they went, and deliver builds in conjunction with their releases. And because we have such a good relationship also with Unreal, we could work as a team and really like I said, roll up our sleeves about this individual experience, knowing that if Leighton was experiencing this problem, like other people would as well. And it helps us build a better, you know, overall solution. So it's great. And it's great that we get to spend the time and effort to do that.
Great, thanks, Michael and Jeff. Next, we have a couple of people, Tim and Andreas, our friend from Lilium, asking about the placement of the high resolution area inside Varjo headsets and how that relates to training, especially for pilots who need to be able to look downward when operating an aircraft, for instance. So any comment on that, Urho, from the product side?
Yeah, so of course, like always with products, you have always things that you would want to be improving, and we're very conscious about the need to have slightly bigger field of view for the human eye resolution, slightly different placement of it and so forth. And I really wish I would be able to talk about what we have been working on that one. And the time will come to answer that one really properly, but not today.
Thanks, Urho. Then we have actually a lot of questions about hand tracking. So I think this one is for Steve, Connie, the Boeing team. So any consideration towards using the Varjo VR2 Pro model with integrated ultra-leap hand tracking in the future to enable more natural hand interactions in the training?
Absolutely, we would like to be there in the future. At this point, we were far enough along in our development and really ready to dive in and get training. We didn't take the time to do that at this point. Using the controllers really allows us to get started with some training, but we certainly in the future would like to incorporate the hand tracking. much more realistic experience.
Thanks. And a related question, how is the haptic and tactile feel handled now in your current training with the switches and the hand controllers?
Leighton, you want to handle that?
Yeah, sure. So, I mean, one of the advantages of hand controllers over optical hand tracking systems is you can actually get some haptic feedback through the vibration motors embedded in the controllers. So, you know, the other thing to consider between controllers and optical tracking is latency tends to be much better in controllers, and accuracy as well. So we've experimented a lot with optical tracking systems. Definitely excited to use Varjo's more in the future. And I think all of those will improve. And I think that's definitely more in the future because at the end, you want your hands free to grasp. Imagine a sort of a mixed scenario where, you know, you've got a joystick which you can grab, but everything else is virtual. And so you can interact with the joystick to do really fine control motions of a spacecraft, but you don't want to have to build an entire flight deck. And that's where optical hand tracking has massive advantages, and that now you don't have anything in your hands and you can support that scenario. So
yeah,
hopefully that answers that.
Yeah. Sebastian, anything to add on the use of haptic devices in this kind of complex simulations? Any comment from you for this?
The haptic systems, as well as the kinesthetic cues systems, all the motion cueing systems, etc., that you want to add in a simulator, can sometimes be a bit tricky to integrate, you know, if you start from scratch. So we've been working on two projects to create a generic plugin for anything haptic as well as anything motion cueing related. These are two plugins that we made available on our GitHub set of plugins for Unreal. So it allows users and developers to create the link between, you know, these tangible worlds to make sure that they can touch things and that they can feel things that are coming from their simulation systems. So you can find them if you can't find them because they're buried somewhere on GitHub. Just, you know, send us a line. We'll help you to you know, create these bridges between the hardware technology and Unreal.
Thanks, Sebastian. Next, we have Bartosz commenting that the visuals are fantastic. Thanks. I'm sure the Boeing team appreciates, after so many iteration rounds, that feedback. I wonder, what were your hard requirements regarding the latency? Was 90 frames per second enough? Leighton, Connie?
Connie, do you want to have a go at this? Or?
Yeah, no, you take it.
Yeah, so 90 frames a second is enough for, you know, immersion and presence effectively to if you can keep that stable. You know, we had to do some level of optimization, obviously, for the internal environment. The models were originally based off the design data from the actual Starliner program, so we had to turn those into real-time friendly models that we could run at 90 frames a second, and similarly for the International Space Station and the Earth, we had to do some optimization there. So in terms of latency, you know, I think you're always trying to stay under 20 milliseconds for virtual reality, and that's pretty important, and you'll start noticing if you don't achieve that. But you should also consider you've got a sort of a visual latency loop or a sensory motor latency loop where you can move something in VR and it updates your visual stimulus through the HMD. But there's a secondary loop about the simulation update as well. In other words, when I flick a switch, how long does it take for the simulation state to update and turn on a light or adjust the display? And so we had to keep that very low as well. So that was the secondary challenge on top of that.
Thanks. Then we have actually, I think, about a dozen questions about the potential of using mixed reality for this training application. So Connie, you mentioned in the presentation that that's something that you're considering for the future, but could you talk about the benefits of integrating Varjo's mixed reality XR1 headset into this training system?
Yeah, the big advantage there would be that we wouldn't have to have the controllers. You would be able to use your own hands to interact with things. Some other things come up then. We would need to have probably a couple of the controllers that we use for flying. We may need to have physical joysticks, for example, that you could actually grab onto. So it's something that we're certainly considering. I think there's big opportunity there. We have not hardly broached the subject as far as actually getting into doing that kind of development yet.
Yeah.
Certainly on the horizon.
Yeah. And I know that, Sebastian, you've been excited about the collaboration between Varjo and Unreal Engine on the mixed reality side. Any reflections from you on this?
Well, that's been a journey, as you mentioned. I mean, Varjo and the teams at Epic have been working, together in a dance for years. Before this year, where things started to move to a more active state. We're really happy to see Varjo evolving towards OpenXR and have things more natively integrated with Unreal. That will accelerate a lot of work, and Connie, Leighton, and the team at Boeing will be able to benefit from that directly. They will be one of the first ones to be able to jump on solutions like that. So we're really happy to support the effort that you're putting in place, because we think it's the future to go to open formats, to things that allow others to play nicely together is the way to go, and we're really excited about that.
Great. Then we have a question about the length of this development cycle for a system that we have demonstrated. So how large of a team supported this? Would be great to hear from Jeff comment on this. You've been working with the Boeing team from the Varjo side since day one, and then followed by both Boeing and Unreal. So how long did the development process of building this take, and what kind of an effort was it?
Well, one thing that was really a nice moment is when we launched our Steam VR integration, the Boeing team was able to at least visualize at a lower frame rate what the cockpit would look like without finishing the native integration. So it provided a really nice proof of concept before moving forward. And then I'll probably pass that off to Connie and Lee, but I think it was a matter of months between that moment. But in the project's entire scope, it was quite some time, maybe over a year. But Leighton, how would you answer that?
Yeah, I think we spent a lot of time working with Varjo on early builds of both hardware and software for other projects within Boeing, and then Starliner came along and benefited from some of that work. And the initial build of Starliner, Connie, I think, was about 6 weeks to get the first sort of public version out. That was not sim integrated. I think we probably spent another couple of months, 3 months doing sim integration, and then it sort of ebbed and flowed naturally for about the last year as we focused more on kind of networking and training and what other things that we need to do to get it to the state where astronauts are really happy with it as a training device. Do you want to add anything in that, Connie?
No, that's about right. It was about 5 or 6 weeks for the initial VR simulation. And then, like you said, another several months, we got it integrated with the back-end simulators. And I'd say for a year or so after that, we struggled with the networking connectivity issues and finding the right headset and things like that before it all pulled together. So probably a year and a half start to finish, but certainly not full time.
Yeah, a lot of that networking time was waiting for NASA to turn the lights on, so to speak,
Yep.
Rather than us doing heavy development. Probably the other thing worth noting on that one is, we didn't build the simulation software for this. We used the same simulation software that was used in the physical simulators that currently train astronauts. So a huge amount of development time went into that by the Houston team, and shout out to Jim May, who really spearheaded that and helped us with that integration.
Yeah.
Thanks a lot. And speaking of the kind of feedback from astronauts, Patrick is asking about the reactions of the astronauts once they've trained with the system. So do they need to relearn the movements or operations once they use the real hardware? Connie, any comment for that?
Sure, or Steve, I don't know if you are able to jump in. No, they do not need to relearn any movements. Hey, Steve. The VR system is not the first interaction that they have, so they generally are introduced to things on the physical simulator. Then the VR is kind of just practicing, and then they do their final checkouts, of course, on the physical simulator. But Steve, you want to add to that?
Yeah, first of all, whenever Chris has been doing this, he has loved it. He has been blown away by how intense it is, how immersive, I should say, it is. And the idea behind this VR simulator is that there shouldn't be much of a difference between that and the physical simulator. That's what they're going for, of course. And from everything that Chris has seen and said so far, they are really in good shape on that. Since obviously you're not training them to fly the simulator, you're training them to fly the spacecraft itself. So that's really what that headset and what that immersive environment requires. And I should point out that it's all connected to, as they've alluded to mission control systems and everything like that. So the flight controllers and the team of astronauts all keep training together and in that headset environment. And they aren't learning anything they're going to have to unlearn later. Hope that covers it.
Great, thanks. I think we have time for one more question. So Connie, you have spoken about sending the headset to international space stations for astronauts to train right before coming back to Earth to train their landing procedures. What would this require from a technical standpoint from Varjo, Unreal, and Boeing?
I think that our couple of stumbling blocks there, we would need a set of simulation software that would run on a laptop. We would probably not at that point be running networked back to the systems on Earth. So something that would run on a laptop, but probably at this point, the biggest challenge is a headset that would run in 0G. And that's probably more a question for Sebastian or Jeff, who can talk about the back end pieces or the hardware, I guess for Jeff, the hardware and why it doesn't currently run and work in 0G.
Oh, I don't know. I would throw that right over.
I mean, if you guys are willing, let's go and try it out on a 0G environment. Like, I'm all for it. Let's make it happen.
Yeah, if you can get us one, we'll figure out how to test it.
Are you in Unreal, folks? Sebastian, Michael?
So, well, from our point of view, I mean, zero gravity and complex universes is what we deal with all the time in our gaming side of things. We're used to science fiction, so we're ready for science.
Awesome.
Fantastic.
Hey, thank you so much, Sebastian, Connie, Leighton, Steve, Michael, Jeff, and Urho. Our time is up. Before you head off to your work day, we'd like to invite you to our next webinar. So if you enjoyed this session, we are hosting next week another webinar with our partner Lockheed Martin. We'll share the registration link with a thank you note for this webinar. So you're welcome to join that. It's on October 15th. And if you have any questions about Varjo using our products for training and simulation, please reach out to Jeff, who you just saw here. Here's his email address, or you can contact us anytime at contact.us@varjo.com. But on my behalf, thanks Urho, thanks all of our fantastic attendees. It was great to have you here. Have a fabulous day.
And thank you, Anski, for hosting this session.
Thanks.
Thank
my
you
pleasure.
very much, everyone. Thank you, Anna, for moderating us.
Bye.
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 Thanks, everyone.